Well, welcome to this online revision session for AQA FP3, in which we're going to look at the June 2011 question 4 on the first order differential equations and their solutions. In this particular question we're going to be using the integrating factor, and then once we've found the general solution we're going to find a particular solution for the conditions that have been provided. Well, before we start we need to check carefully that the equation is in the form for which we can obtain the integrating factor. So we've got a single dy by dx, then a function of x, cot x times y is equal to some other function of x. So to obtain our integrating factor we know we've got to do e to the power of cot x dx. Now in order to do that integration we need to think of cot x as being cos over sine, and as soon as we write it in that form we should then think the top cos x is the differential of the bottom, the sine x, so this can be done as a substitution of u equals sine x, or you know that the answer will be ln of sine x. So this becomes e ln of sine x. And so if that's the case, we know that e and ln are inverse functions, so our integrating factor is just multiplying through by sine x. So if we do that now on the equation we're given, we will get sine x dy by dx plus, now cot x we know is cos over sine, so when we multiply by sine x this will just become cos x times y, and that will equal sine 2x multiplied by the sine x. Now the left hand side, we then know that this can be rewritten as a differential, and it's the differential will be the integrating factor, which is sine x multiplied by our function y dx. And we can see that if we did differentiate sine x times y we would get those two terms above, so that's just fine. And on the right hand side obviously we've still got the sine 2x, but at some point now we're going to integrate both sides, and integrating the sine 2x sine x we're going to need to change the sine 2x using the double angle formulas, and if we do that we know sine 2x is twice sine x cos x, so this is going to become twice sine squared x cos x. So now if we integrate both sides we get y sine x equals, and now we've got to integrate this. Well, if we just write it firstly as this, sine squared x cos x dx. Now we can see that the differential of sine is cos x, so if we use a suitable substitution like u equals sine x, then du by dx will equal cos x, and so this right hand side will just become the integral of 2u squared du, and so if we then substitute back, we're going to get y sine x equals, the differential of this is 2/3 of u cubed, sorry, the integral is 2/3 of u cubed, so that becomes 2/3 of sine x cubed plus a constant. Okay, now having got the general solution to our first order differential equation, we know that when x equals pi by 6, y has to equal a half. And so if we substitute those into here, we've got a half times the sine of pi by 6, and the sine of pi by 6 we should also know as a half, and that must equal 2/3 of the sine of pi by 6 cubed, which is an 1/8, plus c. And so what have we got? Well, that's going to give us a quarter minus a 1/12. And a quarter minus a 1/12 is 3/12 minus a 1/12, which is 2/12, which is 1/6. So c is equal to 1/6. And so our particular solution to this problem is going to be y sine x equals 2/3 of sine cubed x plus 1/6. Well, 10 marks for this particular question. So again, working through finding the integrating factor, you're going to get a mark for attempting the integration, a mark for actually getting the correct value of the ln sine x, and then a mark for getting the correct integrating factor when you simplify the e to the ln sine x. Then for coming up with the correct form from there, we will get 1 mark. For then obtaining the correct integral that we need to integrate, we'll get a mark. For then using the double angle formula to simplify it, there will be a mark for that. And then your method, whatever it is, whether it's substitution or knowing how to use the ln part, that will give you a mark for an appropriate method, and then an accuracy mark for getting the correct form of that general solution. And then attempting to do the substitution with the pi by 6 and the half, that will give you a method mark, and then finally an accuracy mark for coming up with the correct value of c to complete your solution. Hope you found that solution helpful. For more solutions and help with your revision, please go to the Further Maths Support Programme website.